Welcome to today's deep dive. We've got a really fascinating one for you today.
Yeah, we really do. It's quite deceptive at first glance.
Totally. Because today we are looking at a source that, if you just glanced at it over someone's shoulder, it looks incredibly basic. I mean, we are literally talking about identifying squares, circles, and triangles.
Right, primary school stuff.
Exactly. But we are going to completely dissect this material today because what appears to be a simple geometry curriculum for early learners is actually hiding a surprisingly rigorous framework for adult debate.
It really is. It's about logical communication.
Yeah. So if you are, say, prepping for a high-stakes meeting or trying to build a bulletproof argument, or even if you're just curious about how human beings construct a defensible logical premise, you are in the right place.
You absolutely are.
Our mission today is to explore the claim evidence reasoning framework, commonly known as CER. And we're going to do that by looking at how it's used to teach 4 specific geometric concepts.
And, it is a fascinating piece of source material precisely because of that contrast.
The contrast between the simple shapes and the complex logic.
Exactly. The concepts being taught, like counting sides or identifying a rectangle, they're foundational.
Right.
But the cognitive architecture being demanded of the learner is highly advanced.
Right. It's asking a lot of the brain.
A huge amount. We are looking at a system that forces an individual to separate their gut instinct from empirical data. And then it requires them to explicitly articulate the methodology that connects the two.
Wow.
Yeah, that is not just a math lesson. That is epistemology.
Epistemology, the study of how we know what we know.
Precisely. And whether you are a parent sitting at a kitchen table or an educator building a curriculum or, a corporate executive trying to explain why a new strategic initiative is necessary.
The mechanics of proving your point are identical.
They are identical. You have to make a claim, provide evidence, and explain your reasoning. And this framework distills that into 3 simple actions: tell, find, and show.
Tell, find, and show. I love that. It's essentially a blueprint for critical thinking.
It really is.
But before we even get to the first shape, we need to spend some time on the visual layout of these slides. Because the design choices here are not just aesthetic, they are heavily functional.
Very much so.
So for you listening, try to picture this. The screen is divided into 4 brightly colored, rounded quadrants, and there's a distinct gray side panel on the right.
Yeah.
And this layout repeats across every single lesson we are going to discuss today.
And that repetition, that is a deliberate strategy to manage cognitive load.
Cognitive load meaning how much our brain is processing at once.
Exactly. Cognitive load refers to the amount of working memory resources used by the brain. When you introduce a new complex problem, you don't want the learner spending mental energy trying to figure out where to look on the page.
Or how to organize their answer.
Right. So by providing a fixed, predictable visual grid, the framework offloads the structural work. The page does the organizing for you.
Which frees up your brain.
Completely. It allows the user's brain to focus 100% of its processing power on the actual content of the argument.
That makes perfect sense. The structure becomes invisible so the logic can take center stage.
Exactly.
So let's break down that grid for you guys. In the top left corner, we have the question box. It is a soft blue featuring a large, slightly playful blue question mark.
And positioning the question in the top left is standard, sure, but giving it a dedicated color-coded quadrant serves a specific psychological purpose.
What's that?
It isolates the variable. Because in complex arguments, it is incredibly easy to lose the plot.
Oh, tell me about it. You go down a rabbit hole.
Right. You start gathering evidence, you get deep into the weeds of your reasoning, and suddenly you forget what you were originally trying to prove or disprove in the first place.
Right.
So the blue quadrant acts as a visual anchor. Whenever the cognitive demand in the other boxes gets too high, the eyes can naturally drift back to that top left corner to recalibrate. It just asks, what is the core objective here?
It grounds you. I love that. Okay, so moving clockwise to the top right, we hit the tell box. And this one is shaded red.
The tell box.
Yeah, the header explicitly links the simple action word tell with the formal academic concept of a claim.
Right.
And the subtitle instructs the user to tell what you think. Plus, there's an icon of a pink squiggly human brain. Inside the box, we get a sentence stem. It just says, I think the answer is blank.
And the iconography is doing a lot of heavy lifting here. The brain icon signifies that this specific step is internal and subjective.
It's all in your head.
Exactly. It represents the immediate cognitive processing that happens right after you read the blue question box.
Yeah.
Is your hypothesis.
Okay.
But what's really crucial here is the phrasing. I think the answer is. It lowers the effective filter.
It makes it less intimidating.
Exactly. It provides a low-stakes entry point into making a formal claim. It acknowledges that at this stage, you don't necessarily have the proof yet. You are just validating an intuition and putting it on the record.
It's a safe space to take a stance.
Exactly.
But obviously, you can't stay in that subjective space if you want to actually win an argument.
No, you cannot.
And that brings us down to the bottom left quadrant, the fine box. It's shaded a vibrant green.
The evidence phase.
Right. The header connects find with evidence, and the subtitle says find the proof. The icon shifts from an internal brain to an external tool, a classic magnifying glass.
I love that shift.
Me too. And the sentence stem here is just, I see blank.
This is a massive cognitive pivot. If the red box represents the subjective internal world, the green box demands engagement with the objective external world.
You have to look outward.
Yes. The framework is actively halting the user's reliance on assumption. The magnifying glass icon tells you that you must now look closely at the source material provided in the question box.
You actually have to look at the shapes.
You have to extract tangible, verifiable data points. The phrase "I see" forces empirical observation. You cannot write, I feel like it's a square. You have to document what is visibly present.
It forces you to play detective.
I see this.
So we have our subjective claim, we have our objective empirical data, and that leads us to the final colored quadrant in the bottom right. The show box.
Yellow box.
Right, it's shaded yellow, linking show with reasoning. The subtitle demands that you show how you know. The icon is a yellow pencil, and the sentence stem is, I know this because blank.
And this is the nexus. This is where the argument either holds together or falls apart.
The moment of truth.
Truly. The pencil icon implies action and synthesis.
Right.
It is no longer sufficient to just have a thought or to simply point at a fact. You now have to forge the logical link between the two.
Right.
The reasoning phase is notoriously difficult to teach, and frankly, it's where most adult arguments fail.
Oh, absolutely. We're great at shouting our claims.
We are very good at stating our claims,
Mhm.
and we can usually grab a random statistic to serve as evidence, but articulating the exact mechanism by which that statistic validates that claim requires a distinct higher-order skill. I know this because it forces the articulation of methodology.
It's the connective tissue of the whole argument. And then anchoring the entire right side of the slide, outside of the four colored quadrants, is a gray side panel. This panel holds a word bank and a section titled, Put It All Together.
And that gray panel functions as linguistic scaffolding.
What does that mean exactly?
Well, the word bank supplies the precise academic vocabulary needed to elevate the argument from casual observation to authoritative analysis. And the put it all together section is the culmination of the exercise.
It's where it all comes to life.
Right. It takes the modular, fragmented sentences generated in the red, green, and yellow boxes and synthesizes them into a cohesive paragraph.
That is so smart.
It demonstrates to the learner that by following these distinct micro steps, they have organically constructed a macro argument.
It completely demystifies the process of writing a persuasive essay. You don't just stare at a blank page and panic. You just fill in the quadrants and assemble the pieces. So let's see this in action with segment 1, which is lesson 1 in the material. We're starting with the absolute foundational blocks of spatial recognition. Let's call this the geometry of counting.
I like that. And it is the perfect starting point because the geometric concept is universally understood, which allows us to focus entirely on the mechanics of the CER framework itself.
Right. The blue question box sets a very straightforward objective. It asks, which shape has 4 sides? And the visual provides 3 solid black shapes, a circle, a triangle, and a square.
Now, for anyone who has basic pattern recognition, the answer is instantaneous. The brain doesn't even need to consciously count. It just recognizes the squareness of the square.
Right. You just know it.
But the framework is designed to interrupt that automatic processing. It forces the brain to slow down and map the journey to that instantaneous conclusion.
So we move to the red tell box to make our claim. The prompt is, I think the answer is, and the source fills in the square. It's a very short declarative fragment.
But notice what happens when you take an unspoken intuition and force it into the structure of a formal claim.
It changes it.
It does. In a standard classroom, a student might just point or shout out the answer. But by placing the square into a box labeled claim, the framework elevates a simple answer into a defensible position.
You're staking your territory.
Exactly. You aren't just identifying an object, you are establishing the central premise that the rest of your cognitive labor must now support.
But a raw premise isn't enough. We have to drop to the green find box to get our evidence. We need our magnifying glass.
Right.
The prompt I see is completed in the source material with a few accepted variations. It suggests you could write 4 sides, or it has 4 corners, or the sides are all equal.
And what stands out here is how the framework handles multiple valid empirical observations. The learner has to actively use that magnifying glass.
They can't just guess.
No, they can't rely on the definition of a square they have in their head. They have to look at the specific black shape on the screen and extract data. When they write, "I see 4 sides," they are practicing isolation.
Meaning they are isolating the one trait that matters for the question.
Precisely. They are isolating the defining characteristic that fulfills the criteria of the blue question box.
Mm-hmm.
And the fact that the source accepts corners, sides, or equal length as evidence is a crucial lesson in logic.
Evidence is not always singular.
Exactly. Different valid data points can be used to support the exact same claim, provided they are verifiable.
But wait, isn't there a risk here?
What do you mean?
Well, if the question asks which shape has 4 sides, and the evidence provided is I see 4 sides, aren't we just caught in a loop? We haven't actually proven anything. We've just repeated the criteria back to ourselves.
That is exactly the trap of a tautology.
A tautology.
Yes, where an argument merely repeats the premise in different words. And that is precisely why the yellow show box is the most critical component of this entire deep dive.
Okay, lay it on me.
If the reasoning box just said, "I know this because a square has 4 sides," the argument would collapse into a tautological loop. It would be entirely circular.
So how does the framework break the circle? Let's look at the yellow show box for our reasoning. The prompt is, I know this because, and the provided answer is incredibly active. It says, I counted each corner side on the shape.
It breaks the circle by introducing an auditable methodology. I counted.
Wow.
The reasoning here isn't a passive recitation of a geometric rule. It is a physical or conscious mental action. It shifts the burden of proof from relying on authority.
Like knowing what a square is supposed to be.
Right. To active, independent verification.
I counted. It seems so mundane, but it completely changes the nature of the argument.
It grounds the epistemology. How do you know the evidence is real? Because you performed a methodological action to verify it.
That makes total sense.
And this is a profound lesson for adult communication. When you present data in a meeting, the most skeptical voice in the room isn't going to argue with your claim immediately. They are going to question your methodology.
Every single time.
If you say, our customer satisfaction is down, and your evidence is a drop in a specific metric, the reasoning must explain how that metric was gathered.
I know this because we conducted a blind survey of 1,000 users.
Exactly. The action, the equivalent of counting the sides, is what gives the evidence its weight.
It's the proof of the work. You are showing your logical work.
Exactly.
Let's look at the gray side panel to see how this all comes together. The word bank for lesson 1 includes circle, triangle, square, side, corner. These are the basic linguistic raw materials.
Right.
Then we have the synthesis paragraph. My answer is the square. I see the square has 4 sides. I know this because I counted each side on the shape.
Just listen to the structural integrity of that paragraph.
Yeah.
We have moved from a fragmented internal intuition to a robust, logically sequenced argument.
It flows perfectly.
The linguistic scaffolding has allowed the user to weave a narrative that flows naturally from proposition to empirical observation to methodological proof.
It's a miniature, perfectly constructed essay. And what is so elegant is that the user never had to stare at a blank screen and figure out how to write an essay. They just answered 3 highly specific color-coded prompts, and the architecture of the framework generated the essay for them.
It's an incredible tool for overcoming writer's block or analytical paralysis. If you are ever struggling to articulate a complex position, reverting to this modular approach is highly effective.
Break it down.
Yes. What is the explicit claim? What is the tangible observation? What action or rule explicitly connects them? Isolate the variables before trying to write the narrative.
Okay, that was lesson 1. We have mastered basic identification and methodology. But the curriculum immediately raises the stakes. We are moving into segment 2, which introduces the concept of relational logic. I call this the power of comparison.
This represents a significant leap in cognitive demand. The brain is no longer just pattern matching a single object against a known definition.
It has to juggle.
Right. It must now hold 2 distinct concepts in its working memory simultaneously and evaluate the delta, the difference between them.
The blue question box sets the stage. How are a triangle and a square different? And the visual provides a line drawing of a triangle on the left and a square on the right. There are little gray arrows pointing around the perimeter of both shapes, acting as subtle visual hints.
Those arrows are a brilliant piece of instructional design. They gently guide the learner's visual attention toward the relevant feature.
The perimeter.
Exactly, without giving away the actual answer. They are scaffolding the find step before the learner even consciously reaches it. It directs the magnifying glass.
We move to the red tell box. We need our claim. The prompt, I think the answer is completed with, they have a different number of sides.
Stop and look at how the framework adapts here. In the first lesson, the claim was just pointing at a noun, the square. Now, the claim is entirely relational. They have a different number of sides. The red box proves to be highly elastic. It teaches the user that a claim doesn't just have to be the identification of an object. It can be the assertion of an abstract condition or relationship.
The brain icon is definitely working harder here. It has to perceive the lack of connection between two entities. So we drop down to the green find box to gather evidence for this relationship. The prompt I see gives us, a triangle has 3 sides and a square has 4 sides.
This is a masterclass in comparative argumentation. Notice what is required here. The evidence must satisfy both halves of the comparative claim.
You can't just talk about the triangle.
No. You cannot merely state, I see a triangle has 3 sides, and consider the job done. That only proves the status of one variable. To prove a difference, you must establish the empirical baseline for both subjects.
It's like trying to prove a weight disparity on a scale. You can't just put weights on one side and claim it's unbalanced. You have to put both items on the scale to demonstrate the delta.
Precisely. And this is a trap that professionals fall into constantly in the real world. Think about competitive analysis or pitching a new vendor.
Oh, this happens all the time.
If you are arguing that software A is superior to software B, your argument is fundamentally weak if your evidence only consists of a list of features for software A.
You have to talk about B as well.
You have to put the magnifying glass on both. You have to explicitly document the data for A and the data for B to make the comparative claim irrefutable. The framework demands that the observation be comprehensive.
That is a highly practical takeaway for you listening. Comprehensive observation prevents asymmetrical arguments. So we have our dual evidence, 3 sides and 4 sides. We move to the yellow show box for our reasoning. How do we connect the claim of difference to this dual evidence? The source material provides, I counted the sides on the shapes.
And here we see the value of a strong foundational toolkit. What is the methodology? It's the exact same action we used in Lesson 1.
We are still just counting.
We are still just counting. The curriculum is proving to the learner that you do not need to invent a brand new logical paradigm just because the problem got harder.
Right.
The basic tools of empirical verification that you mastered in the first step are perfectly adequate for solving the complex comparative problem in the second step. You just have to apply the tool more rigorously, in this case counting twice instead of once.
It demystifies complexity. Hard problems are often just basic problems layered on top of each other. Let's look at the gray side panel for this comparative lesson. The word bank gives us triangle, square, sides, and a crucial new addition, the word different.
The inclusion of different in the word bank is pivotal. It elevates the word from a casual conversational descriptor to a formal academic concept that requires rigorous proof. It serves as the linguistic glue that holds the dual evidence together.
Let's read the final synthesis paragraph to hear how that glue works. My answer is that a triangle and a square have a different number of sides. I see the triangle has 3 sides and the square has 4 sides. I know this because I counted the sides on each shape.
The transition from the internal relational thought to the specific external data points to the methodological reasoning is seamless. It is teaching the architecture of comparative analysis.
Step by step.
If you want to argue that two things are not the same, state the conceptual difference clearly. Provide the specific balanced data points for both entities, and then explicitly state the mechanism by which you acquired those data points. It leaves no room for ambiguity.
The progression here is so smart. We've identified a baseline, we've compared 2 baselines, but now, in segment 3, the deep dive takes a sharp turn. The curriculum actively tries to trick the learner. Let's call Lesson 3, the rectangle trap.
The trap.
This is what happens when your eyes deceive you and your logical framework has to override your assumptions.
This is where the true value of the claim evidence reasoning framework is revealed. Up until now, the framework has been used to confirm obvious truths. Now, it is going to be used to dismantle a false premise.
The blue question box sets the trap. The prompt asks very directly, is this shape a rectangle? And beneath it is a drawing of a blue shape. It is a quadrilateral. It has four straight solid sides, but it is very clearly not a rectangle. It
Okay.
looks like a trapezoid. The top horizontal line is shorter than the bottom horizontal line, meaning the vertical sides slope inward. The angles are obviously not 90 degrees. It is a visual lure designed to see if you are applying all the rules of a shape or just the superficial ones,
And the human brain relies heavily on heuristics.
meaning mental shortcuts.
Yes, mental shortcuts that allow us to process information quickly. One of the strongest visual heuristics is pattern matching. The brain sees four distinct straight sides, and it immediately wants to categorize the object into the most familiar four-sided schema it possesses, which is the rectangle.
Right.
The question itself, is this a rectangle, acts as a subtle psychological nudge, leading the witness. The framework is forcing a collision between a fast heuristic assumption and a slow, strict definition.
It's testing whether you will surrender to the shortcut or rely on the logic. And the red tell box handles this collision with incredible force. The claim isn't a measured sentence. The source material provides a single word, punctuated with an exclamation point. No.
The brevity of that claim is powerful. It highlights an essential lesson in rhetoric. A claim can be an emphatic negative assertion.
You can just say no.
Refuting a false premise requires confidence. It takes intellectual courage to look at a leading question, recognize the visual trickery, and firmly plant your flag on a definitive no.
But declaring no is the easy part. Proving a negative is notoriously difficult. How does the framework handle it? We drop down to the green find box. We need our empirical evidence. The prompt I see is completed with a sentence that is far more nuanced than anything we've seen so far. It reads, I see four straight sides, but the angles are not 90 degrees.
This specific phrasing is a masterclass in advanced argumentation. What is the learner doing here? They are actively acknowledging the misleading evidence while simultaneously deploying the disqualifying evidence.
They are saying the quiet part out loud. Yes, I see the four straight sides that you used to try and trick me.
Exactly. They are conceding a superficial point to strengthen their structural argument. In debate, this is a highly sophisticated tactic.
How so?
By explicitly acknowledging the four straight sides, you demonstrate to your opponent, or in this case the curriculum, that you are objective. You have surveyed the entire board. You aren't ignoring data that conflicts with your definitive sign.
You see the similarities.
But then comes the rhetorical pivot, the word but. But the angles are not 90 degrees. You take the magnifying glass off the perimeter and focus it squarely on the structural flaw. You isolate the specific, measurable criteria that causes the premise to collapse.
It's the yes, but strategy. Yes, it has four sides, but the angles fail the test. So why do the angles matter? That brings us to the yellow show box, our reasoning. The prompt, I know this because it gives us this answer. I know this because a rectangle needs to have four 90-degree angles.
Stop and analyze the evolution of the logic here. In lessons 1 and 2, the reasoning was entirely empirical and experiential. The proof was grounded in a physical action. I counted.
Right.
But here, you cannot just count your way out of the trap. Counting the sides gave you the number 4, which is what created the trap in the first place. The reasoning here is no longer an action. It is the application of an abstract, definitive rule. A rectangle needs to have four 90-degree angles.
We've moved from physical methodology to theoretical law.
We have moved from inductive reasoning, building a conclusion from observations, to deductive reasoning. The framework is subtly walking the user through a formal, logical syllogism.
Let's unpack that term, a syllogism. Break down exactly how this fits into that structure, because that is a vital concept for our listeners.
A syllogism is a form of deductive reasoning where you arrive at a specific conclusion by examining two other premises. You have a major premise, which is a general rule. You have a minor premise, which is a specific observation. And from those two, you deduce the conclusion.
Okay, so map the blue, green, and yellow boxes to the major premise, minor premise, and conclusion for us.
Gladly. The major premise is the abstract rule we just found in the yellow show box. All rectangles must have four 90-degree angles. That is the universal law.
Got it.
The minor premise is the empirical observation we made in the green find box. The specific shape does not have 90-degree angles.
Right.
Therefore, when you apply the minor premise to the major premise, the inevitable conclusion is the red tell box. No, this is not a rectangle.
Major premise, minor premise, conclusion. Yellow box, green box, red box. That is incredibly satisfying. It teaches the learner that some truths cannot be verified merely by looking. They must be verified by testing the object against an established set of criteria.
And look at the gray side panel for Lesson 3 to see how the vocabulary scales to meet this deductive challenge. The word bank includes rectangle, sides, degree, angle, parallel, equal.
That is a massive upgrade in academic language. Parallel and equal aren't even used in the final synthesis paragraph, but they are provided as tools.
Because they introduce the language of precision and structural integrity. The framework is seeding the environment with alternative avenues for deductive reasoning.
Oh, I see.
A learner could have constructed a different, equally valid syllogism using those words. They could have said, I know this because a rectangle needs to have equal opposite sides, or parallel opposite sides. The framework provides the high-level vocabulary and lets the user choose their specific path of refutation.
Let's read the final synthesis, the put it all together section. My answer is no. This is not a rectangle because it has 4 straight sides, but it does not have 90-degree angles.
It is a devastatingly effective sentence of refutation. And if we pull back and look at the real world, this specific cognitive exercise, identifying the rectangle trap, is arguably the most important skill an adult can possess in the modern information economy.
How so? Connect the geometry to the real world for us.
Think about how often we are presented with scenarios that possess the superficial markers of legitimacy, the 4 straight sides, but entirely lack the underlying structural integrity, the 90-degree angles.
I see where you're going with this. It's the anatomy of a scam. A phishing email is a perfect example. It has the 4 straight sides, it has the correct corporate logo, the right color scheme, maybe even the right font.
Exactly.
Your brain uses a heuristic, pattern matches the logo, and assumes it's from your bank. But if you apply the magnifying glass to the sender's email address, you realize it doesn't have the 90-degree angles. The domain name is misspelled.
Exactly. Or consider a complex business environment. A proposed marketing strategy might have the 4 straight sides of looking incredibly innovative, using all the right buzzwords, and having a slick slide deck. It looks like a rectangle.
It definitely looks like one.
But if you demand the syllogism, if you force them to explicitly state the major premise of how user acquisition works and compare it to the minor premise of their actual budget, you might find that it lacks the 90-degree angles of a sustainable financial model. The strategy collapses under deductive reasoning.
This lesson teaches you to demand the angles. Don't be seduced by the straight sides. Concede that the presentation looks nice, but apply the strict rule. Have the courage to use that red box and say, no, when the criteria aren't met.
Demand the angles is a fantastic way to summarize the value of deductive reasoning.
All right, we have identified, we have compared, and we have refuted. We have arrived at segment 4, which is lesson 4. The final lesson literally adds a new dimension to the deep dive. We are moving from 2D space into 3D space.
This represents the culmination of the spatial and logical reasoning curriculum. It requires a profound act of mental abstraction. The brain is being asked to interpret a flat, 2-dimensional image on a screen as a representation of a multidimensional reality.
Let's look at the blue question box. The prompt is, which shape is 3-dimensional? The visual provides 2 line drawings. On the right is a simple flat outline of a square, exactly like we saw in lesson 1. But on the left is a wireframe drawing of a cube. It shows the front face, the top face, and the right side face, with angled lines meant to suggest depth going back into space.
Just introducing the phrase 3-dimensional into the prompt is a massive escalation from which shape has 4 sides. It requires the learner to comprehend the concept of a z-axis, depth, existing in a medium that only actually possesses an x and y axis.
So we head to the red tell box to make our claim. The prompt, I think the answer is filled in simply, the cube. We are returning to the straightforward identification style of lesson 1. We aren't comparing, and we aren't refuting.
The claim is structurally simple, but the cognitive mapping behind it is complex. They're identifying an abstract concept dimensionality via a proxy, which is the flat drawing of the cube.
How do we get empirical evidence for an abstract concept? We drop to the green find box. The prompt I see is met with, it has 6 faces.
Let's pause and really analyze the epistemological problem here. The framework is demanding empirical observation, I see. But the learner cannot actually see 6 faces on that screen. The line drawing explicitly shows 3 faces. The rest is implied by the wireframe.
Right. If they rely purely on their optical nerve, they see a bunch of connected lines on a flat plane.
Exactly. So the magnifying glass is turned inward. The evidence is no longer strictly visual, it is conceptual. The learner has to build a mental model of the object, rotate that object in the 3D space of their mind's eye, and extract the data points from that mental model.
Wow.
Stating it has 6 faces proves that they understand that a face is a defining characteristic of a solid object, differentiating it from the lines that define a flat shape. It is a highly sophisticated piece of evidence to select.
The evidence requires imagination. So how on earth do we reason this? We have an abstract concept and internally generated evidence we drop to the yellow show box for our methodology. I know this because. And this is where the curriculum brings it all home in a way that I found genuinely surprising. The source material gives us, I counted each face on the shape.
It is a moment of beautiful curricular symmetry. After the high-level abstract deductive reasoning of the rectangle trap, where we were dealing with syllogisms and theoretical laws, the framework brings us crashing back down to reality. It returns to the foundational, physical action of Lesson 1.
We are back to counting. I counted each face.
It grounds the esoteric concept of multidimensional space in a tangible, relatable, and universally understood action.
But how do you count faces that aren't there? You are counting the faces on your internal mental model.
Yes, and that is the brilliance of it. It reassures the learner. It essentially says, yes, 3D space is a new, bizarre, and complex dimension, but you do not need magic to navigate it. You do not need a new logical paradigm. You just use the exact same tool you used to understand the 2D square on day 1. You point and you count.
That's amazing.
It proves that the most intimidating concepts can often be dismantled and verified using the simplest, most auditable actions. The scale of the problem expanded, the dimensionality of the problem shifted, but the fundamental method of verifying the truth, the active reasoning, remained constant.
That is deeply comforting. Complex problems don't always require complex solutions. They just require the rigorous application of basic solutions. Let's look at our ultimate gray side panel. The word bank has evolved completely to reflect this new dimension. We have faces, sides, vertices, angles, cube, square.
Track the evolution of the vocabulary from Lesson 1 to Lesson 4. We started with sides and corners. A corner is a casual layman's term for a 2D meeting point. Now we have graduated to faces and vertices. A vertex is a precise mathematical term for an intersection in multidimensional space.
The language grew up with the student.
The linguistic scaffolding has matured in lockstep with the learner's spatial awareness. The framework is providing them with the exact terminology required to describe the increasingly complex world they are analyzing.
Let's read the final synthesis paragraph, the last predicate to handle the shame. My answer is the cube. I see the cube has 6 faces. I know this because I counted each face on the shape.
It is clean, precise, and undeniably logical. By following the claim evidence reasoning structure, the learner has successfully navigated from pointing at a flat square to comparing variables to refuting false premises via deductive reasoning to mentally rotating a 3D object and proving its dimensionality. They haven't just learned geometry, they have built an internal engine for generating sound logic.
What an incredible intellectual journey hiding inside 4 simple slides. As we move to wrap up this deep dive, I want to take a moment to reflect on the sheer scale of what this framework accomplishes. We started with the necessity of structuring a raw thought into a formal premise. We learned that a methodology, like counting, is what prevents an argument from becoming a circular tautology. We tackled the necessity of balanced evidence when making comparative claims, avoiding the trap of asymmetrical arguments. We navigated the rectangle trap, learning how to concede superficial facts to dismantle structural flaws using formal syllogisms. And finally, we realized that even the most abstract, multidimensional problems can be grounded and verified using foundational active reasoning. All of this guided by a simple visual grid of blue, red, green, and yellow boxes.
It is a profound testament to the power of structured thinking. And I want to emphasize to everyone listening that the utility of what we explode today extends far beyond an early childhood classroom. The colors and the icons may be designed to lower the effective filter for young learners, but the cognitive architecture they represent is universal and uncompromising. This framework is a defensive tool for navigating modern adult life.
A defensive tool. Explain that.
We exist in an environment defined by information overload and asymmetrical rhetoric. We are bombarded every single day with claims. We see them in aggressive news headlines, in meticulously crafted marketing campaigns, in political speeches, and in the boardrooms where we work.
Right.
It is incredibly easy to feel intellectually overwhelmed. The natural human tendency is to rely on heuristics, to accept the red tell box because the person speaking sounds confident, or to accept the premise because it possesses the 4 straight sides of plausibility.
We fall for the trap because we don't want to do the cognitive labor of demanding the angles.
Exactly. But this deep dive reminds us of our intellectual responsibility to the green and yellow boxes. The CER framework is your defense mechanism against faulty logic and manipulation. Whenever you are presented with a compelling new piece of information or a bold strategic claim, you must actively pause your heuristics. You must demand the specific, verifiable evidence. What do you actually see? And more importantly, you must critically interrogate the reasoning that supposedly links that evidence to that claim. How do you know this? What is the auditable methodology? Did you count the sides, or are you just assuming the shape? If the reasoning is just a restatement of the premise, the argument is a house of cards.
That is a phenomenal takeaway. The framework isn't just for building your own arguments, it's a filter for evaluating everyone else's. So, I want to leave you with a final thought to mull over as you go about your week. Throughout all of these geometry lessons, the yellow reasoning box, the show how you know step, almost always required an active step. It demanded an action. It required counting the sides or mentally mapping the faces or explicitly applying a structural law. The truth wasn't something passively received from authority, it was something actively verified by the individual. Think about the last really strong opinion you held, or a passionate, persuasive argument you heard someone else make recently. Perhaps it was about a new corporate policy or a piece of breaking news. Was the reasoning behind that opinion based on an active personal verification of the underlying facts? Did someone actually do the work? Or was it just a widely accepted assumption passed off as a definitive conclusion? In your own professional and personal life, when you are presented with a compelling claim that looks perfectly neat and tidy, are you taking the time to count the sides yourself? Or are you just seeing four straight sides, assuming you're looking at a rectangle and moving on without ever checking the angles? Thank you so much for joining us on this deep dive into the architecture of logic. Keep demanding the evidence, check the angles, and we'll see you next time.